One of the techniques that organic chemists commonly use to help determine how pure a substance that they've made in the lab is to determine its melting point range. In order to understand how the melting point is affected by an impurity, let's first look at how a pure compound acts when you try to melt it. So if you think about a pure compound, it forms as a solid, a crystalline lattice in which I'm going to represent the molecules with these blue rectangles. And that crystalline lattice has the molecules spaced very evenly within it. Now, those molecules are held together by intermolecular forces, which are the yellow lines here. And those intermolecular forces are what have to be broken in order for the molecules to break apart from each other and go into the liquid phase and melt. So in order to do that, you have to supply the system with enough energy to overcome those intermolecular forces. And when you do that, the molecules will start to separate from each other and go into the liquid phase. As you continue to supply the heat that is needed to break all of the intermolecular forces, then the entire sample turns from solid to liquid. Now, in pure compounds, as I said, all of the intermolecular forces are equal to each other. What this means is it takes the same amount of energy to break all of them down, which means you're going to have a very small melting point range, typically less than a 5 degrees Celsius range. You learned in general chemistry that the temperature of the material absolutely does not change as it melts. However, with the techniques that we are using in the lab, that is not completely true. We actually do see a small range when we are melting an absolutely pure compound. But if you look up literature melting point values, they're typically ranges that are somewhere around 2, 3, 4 degrees Celsius, nothing larger than that usually. Now, if we move on and we look at an impure solid, instead of having that nice, evenly spaced crystalline lattice, when we start to introduce an impurity, which is going to be the smaller green rectangle, what you end up doing is forming a solid that is a little bit disjointed. And as you add more and more and more, you see the molecules aren't really as evenly spaced anymore. What this does is create intermolecular forces that are disrupted, and it leads to some of them being weaker than in the original structure. So now all of a sudden, you end up with needing less energy to break those weaker intermolecular forces. That leads to melting point depression. So now we start to see that the solid will melt at a lower temperature value. The other thing that we see is the intermolecular forces are not all the same. So some of those are able to be broken at a lower temperature than others. So what this does is also broaden the melting point range. So the takeaway from this is that in order for us to judge whether a sample is pure by looking at the melting point range, we're actually looking for two different things. We're looking for the value of the melting point because of the melting point depression, we'll see lower than literature value melting point if the compound is impure, and it goes lower and lower and lower with the more impurity that you add. You will also see that the melting point range is broader. So that's the concept of melting point range as used by an organic chemist. Now what I'm going to do is switch over to a video camera and show you how to prepare a melting point capillary and run the DigiMelt instrument that we have to determine the melting point range of a compound. In lab this week, you are going to be measuring the melting point range of the acetanilide that you recrystallize. So I am going to show you how to prepare your melting point capillary with acetanilide in it, and also how to operate the DigiMelt so that you can measure that melting point range. So the first thing that you're going to need is your compound. This is actually phthalic acid. You guys are going to have acetanilide. You don't need much of it because all you need to load into this melting point tube, and these tubes will be next to the DigiMelts for you. This is a glass capillary tube, and if you look, it's a very, very small tube, And the other thing is one side of this tube is open, one side is closed. This is the bottom, the closed portion. So the only amount of acetanilide that you're going to need to put in is about 1 millimeter or 2 in the bottom of the tube. It really doesn't take much. So what you're going to do is take your compound on a watch glass or a weighing dish, and you're going to take the open end of the tube and you're just going to tap it into the solid, and sometimes you have to scoop it a little bit until you've got about 1 millimeter or 2 inside the tube. Then you should wipe away the outside. You can use a Chem wipe for this. And so now I've put the solid in the tube. It's sitting up here in the top. Now we need it to go all the way down to the bottom of the tube. There are 2 different ways that you can do this. The kind of old-fashioned way is you would tap it on the bottom of the bench, or you can take advantage of the tube tapper right on the DigiMelt. And so I'm going to zoom in for a second here on the DigiMelt. There are, focus, okay, there are 3 little holes here that will each accept a melting point tube. You just put it in with the bottom end, and I'm actually going to put a little bit more in here because it actually fell out. That actually fell all the way in. So you're going to put the melting point tube inside any of those 3 holes, and then you're just going to hit that gray button on the DigiMelt that says Tube Tapper, and this is going to vibrate the tube so that, let me zoom out a little bit, you will be able to see the solid that is currently way up here when I hit that tube tapper is going to rotate very quickly, and if it doesn't go down in one shot, you can always hit it again, and that should make it go down. There. And so now, if I take that out, you can see that white solid is now all the way in the bottom of the tube. Okay, now that you have your compound loaded into the melting point tube, you just need to take the tube that's got the solid down in the bottom, and you need to put it into the heating block. Now the heating block is right over here behind this viewport, and it's difficult to see, but there are 3 little slots right here that can each accept a melting point tube. So I'm just going to put this one into the middle slot and drop it down, and it is going to be nearly impossible from this camera to actually see what's going on inside that viewport. So now what I'm going to do is take the left-hand side of the video here, and I'm going to show you a zoomed-in image of what the tube looks like inside that viewing port. So what we're going to do is wait, because right now the DigiMelt's light is on for the preheat mode. I have set this to hold the temperature on the DigiMelts at 90 degrees or 95 degrees, because the compound that I'm using to do this demonstration is 3-hydroxybenzoic acid, and it has a literature melting point of 104 to 108 degrees. So I want to start about 10 degrees lower than the recorded literature melting point, because I'm not sure exactly how pure this is. This should be fairly pure because it is a manufacturer's bottle. It says 99%, but just in case, I'm going to start it at 95 degrees. So I'm waiting for this preheat light to go from preheat to ready, and what that tells me is, okay, it's holding at that 95 degree temperature, which 93.9 is close enough. Now I've got my melting point tube inside here. I am ready for the DigiMelt to start raising the temperature at a very steady rate. I have this set to 2 degrees a minute, and we're going to keep an eye by looking inside the viewport to see when we see the first little bit of liquid form, and we're going to record the temperature on the display when that point happens. So to bring this into the raise the temperature mode, all you have to do is hit the start and stop button. This is really the only button that you need to press throughout the entire routine. So I'm going to hit start, I'm going to let it start heating up, I'm going to watch for it to melt, and I'm going to record when I initially see liquid and then when the rest of the solid has melted as well, and that's my melting point range. So here we go. So I hit that start button and now it is on the melt mode, and you'll see the temperature is going to start to go up fairly slowly at 2 degrees a minute. And we will just watch the tube and see when we see some liquid start to form. You may see this scope kind of move a little bit. I can't really see it all that well because the camera's in my way, so I'm just kind of popping it up and down a little bit so that I can tell when it starts melting. So I'm going to record the starting melting point as 104.2 degrees Celsius because I can see right on the side some of those little pieces of powder have turned into liquid. So 104.3 is the starting melting point, and now you can see it's really starting to kind of coalesce a little bit, and you can really see at the top of the solid it is starting to melt right up here. I'm just going to take another melting point tube, and now it is really, really getting there. So now we're going to keep an eye, and when the last little bit of that has melted, we are going to say that is the end of our melting point range. And that looks like right there, so we're going to record 105.7 degrees as the final melting point. One thing that you may want to do is kind of raise your tube up a little bit as you're looking at it. You can get a slightly better view of it when you're looking at it in person that way. And so it's as simple as that. The very last thing that you have to do with the melting point, when you are finished recording the melting point range, this is going to continue heating up unless you hit that start/stop button one more time. And so what we want to do is get this to go from melt into cooling mode. So just hit that again, and what that's going to do is allow it to cool back down below that ready preset temperature so that it's ready to go for the next person. And so once you have it in the cooling, you are all set. You can take your melting point tube and throw it in the broken glass. If you think you want to repeat your experiment, that is fine. You can make up another tube. Do not use the same melting point tube, though. You have to start with a fresh sample. The reason for that is if this was impure because you had some kind of solvent mixed in with your compound, while it's sitting there getting heated up inside the heating chamber, you may have actually boiled off that solvent. So that would change the composition of your compound, which would change the melting point range. So you really should start out with a fresh tube every single time. Don't take the same one and run it through the melting point again. That is it. If you have any questions on how to use it during the lab, then your lab instructor or lab assistant would be more than happy to answer any questions that you have. And so we are good to end the video. Bye.